The new generation Boeing 737 is a short to medium range transport jet. The aircraft requires a flight crew and cabin crew as shown here. The 737 NG comes in series as shown here, and minor differences exist between the series. The baseline aircraft for this course and the method to display fleet and series differences is shown in the pop-up. This frame shows the series of aircraft and cabin configuration in our fleet. Actual layout of the cabin will be described in another module. On this frame, you can see some of the limitations for operation of the aircraft. Notice the maximum flight altitude and the takeoff and landing weight limits. Always refer to your manual for up-to-date and specific information. On the following frames, we'll provide an overview of the aircraft features. This frame shows the flight deck layout and seating arrangement. This frame shows the flight deck panels. The primary flight instruments are provided on 4 display units, 2 for each pilot. The primary flight display, PFD, and navigation display, ND, normally appear as shown here. Other displays, such as engine and systems parameters, are normally provided on the center area, where there is an upper and a lower display unit. The overhead panel is very similar to the classic Boeing 737. It consists of panels to control and monitor the aircraft systems. Differences exist in the area of the air conditioning panel, as shown here. The control stand holds various items that are common to a passenger jet, to include the control display units for the flight management system. The glare shield holds the master caution warning lights and the mode control panel, or MCP, for the auto-flight system. The aircraft is equipped with an Air Data Inertial Reference Unit, ADIRU, and is therefore limited to operate from 82 degrees north latitude to 82 degrees south latitude. This restriction is because the ADIRU only has stored magnetic variation for this operating area. The aircraft is serviced on the right side. Notice the location of various service equipment when the aircraft is at the gate. The external power receptacle is located on the right side of the aircraft beneath the first officer's window. The external power receptacle is equipped with a flight jack that allows the ground crew to communicate with the pilots through the flight interphone during pushback or tow and when the aircraft is parked. Pitot probes, static ports, and one angle of airflow sensor are located below the cockpit windows as shown here. One Rosemont total air temperature probe is located below the window on the left side of the cockpit. These items provide air and angle of attack information to the ADIRU. A separate alternate static port on each side provides static pressure to the standby airspeed indicator and altimeter. A pitot tube is installed on each side of the vertical stabilizer. These pitot systems sense airspeed information and deliver the information to the elevator field system. The elevator field system is used to modify the pilot forces according to airspeed and other conditions. Thus, at higher airspeeds, the pilot forces required to move the elevator are increased. The weather radar antenna is located behind the radome in the nose section of the aircraft. The antenna is a flat dish type, typical for a colored radar display. This frame shows the location of various antennas on the aircraft. The 800 aircraft are equipped with a tail skid. This skid is installed on these longer aircraft to protect the aft bulkhead in the event of a tail strike on takeoff or landing. This completes your introduction to the Boeing 737 NG.